Welcome to the DIY Honda Garage channel. The title of this presentation includes the Diagnostic Trouble Code, DTC P0339, which refers to an intermittent interruption in the crankshaft position, CKP sensor circuit. This error is critical for the Honda CRV models between 2017 and 2022, as it can affect engine performance and operation. The CKP sensor plays a vital role in monitoring the position of the crankshaft, allowing for precise timing and synchronization of the engine's ignition and fuel injection systems. When there is an issue detected, it can impact the vehicle's drivability and potentially trigger warning lights on the dashboard. This troubleshooting process will systematically identify and correct the underlying issues causing this DTC to ensure the vehicle operates effectively and reliably. The P0339 Diagnostic Trouble Code indicates an intermittent interruption in the crankshaft position, CKP sensor circuit. The CKP sensor is essential for providing the Engine Control Module, ECM, or Powertrain Control Module, PCM, with the precise position of the crankshaft. This information is used for determining the timing for ignition and fuel injection. The CKP sensor is typically located near the crankshaft, often on the engine block, observing the rotation of the crankshaft to provide accurate readings. A faulty CKP sensor or its circuit can lead to poor engine performance, stalling, or hard starting conditions, as the engine won't know the optimal timing needed for combustion. Therefore, understanding the role and location of this sensor is pivotal for addressing any issues related to DTC P0339. There are several possible causes for DTC P0339, such as an intermittent failure in the CKP sensor itself, which may lead to unreliable readings. Additionally, poor electrical connections at the CKP sensor or within the wiring harness can also jolt the signal being sent to the PCM. Loose terminals at crucial connections can exacerbate these issues, leading to intermittent failures of the sensor circuit. Moreover, damage to either the CKP sensor or the CKP pulse plate can result in incorrect data being transmitted to the PCM. Proper troubleshooting will help pinpoint the exact cause of the problem, which is essential for restoring optimal vehicle function. Symptoms associated with DTC P0339 can vary, but they primarily impact vehicle performance. One common symptom is engine stalling, occurring when the vehicle fails to receive adequate timing information from the CKP sensor. Drivers may also notice poor acceleration, which is a direct result of inconsistent timing affecting fuel delivery and ignition. Furthermore, the check engine light is likely to illuminate on the dashboard, prompting the driver to investigate potential underlying issues. Inconsistent engine performance can lead to an unreliable driving experience, underscoring the importance of timely identification and resolution of DTC P0339. These symptoms highlight why thorough diagnosis is crucial for vehicle performance. For the first troubleshooting step regarding DTC P0339, begin by turning the vehicle to the on mode. This allows the vehicle's systems to initialize without fully starting the engine. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs, ensuring the vehicle's onboard computer is reset. After clearing the DTCs, start the engine and let it idle for a minimum of 10 seconds. This engine idling period is crucial, as it allows the vehicle systems to stabilize and gather necessary data. Finally, monitor the OBD status for DTC P0339 in the DTCs menu of the HDS. If it indicates failed, you will move to the next step for further diagnosis. In the second troubleshooting step for DTC P0339, Conduct a test drive of the vehicle for several minutes. During this time, pay particular attention to engine speed and vehicle speed, which are vital parameters recorded during the troubleshooting process. Monitoring these parameters helps confirm the issue under realistic driving conditions. Again, check the OBD status for DTC P0339 in the HDS menu post-test drive. If the HDS indicates failed, it confirms that the failure has been duplicated, prompting further investigation. If it indicates passed, this may suggest an intermittent failure in the system, but check for poor connections or loose terminals, as they could still be contributing factors. If the status shows not completed, continue idling until a result is logged. For the third troubleshooting step related to DTC P0339, focus on examining the condition of the CKP sensor circuit connectors and terminals. Start by checking for poor connections or loose terminals, specifically at the CKP sensor and the powertrain control module (PCM). It's crucial, as improper connections can lead to intermittent circuit failures. Also, check the engine ground and body ground for proper connectivity, as faulty grounds can significantly impact sensor readings. If the connections and terminals are deemed okay, proceed to the next step. However, if any issues are found, they need to be repaired or tightened to ensure stable operation. In this final troubleshooting step for DTC P0339, the CKP sensor must be physically removed for inspection. After removal, examine the CKP pulse plate for any signs of damage. The pulse plate is critical as it feels the position of the crankshaft, and any cracks or wear can disrupt the sensor's operation. If the pulse plate is found to be damaged, it must be replaced. Should the pulse plate be in good condition, the next course of action would be to replace the CKP sensor itself, as it may still be causing the intermittent circuit issues despite appearing intact. This thorough inspection and replacement process is vital for restoring proper functionality. After completing the necessary repairs, it's essential to verify that the problem has been resolved. Start this verification process by clearing any stored DTCs, again using the HDS. Once completed, conduct a road test of the vehicle to ensure that it operates smoothly without triggering the DTC once more. Observe the engine performance, paying attention to acceleration, responsiveness, and any unusual sounds. If the DTC for P0339 reappears, it will indicate that further diagnostics may be necessary. Confirmation of the repair's success is crucial for the reliability of the vehicle post-repair, assuring the driver that the issue has been fully resolved. To prevent future occurrences of DTC P0339, proactive maintenance is key. Regularly inspect the CKP sensor and its connections. Ensure that there are no signs of wear or damage. Maintaining proper connections and grounds is vital, as they can influence sensor reliability greatly. It's also important to keep the vehicle's software updated, as updates might resolve compatibility issues or bugs affecting sensor reporting. Periodically checking wiring for fraying or other issues can help mitigate electrical problems before they escalate into more severe faults. By implementing these preventive measures, you can help ensure the long-term robustness of your vehicle's engine performance. In conclusion, understanding the CKP sensor's role is crucial for diagnosing DTC P0339 effectively. Identifying intermittent issues often takes a systematic approach, addressing each potential point of failure. Proper connections to both the CKP sensor and the PCM cannot be overlooked, as intermittent connection failures can create significant problems in engine operation. Additionally, adopting proactive maintenance strategies not only reduces the chance of triggering this DTC in the future, but also contributes to the overall reliability of the vehicle. By following this comprehensive troubleshooting guide, technicians can ensure a thorough and informed approach to resolving the reported issue, maintaining the quality and performance expected from Honda vehicles. Please like and subscribe to the channel. See you next time.